This is 4.4 exponential and log equations. The first thing I want to look at is your change of base formula, and you were taught this last year. I just want to review it. It says when you have log base y of x, you can change it to log base x over log base y. And the reason that you do this is because your base is not the same. And here you change your base to be the same, and it would be base 10. If you change it to natural log, it would be natural log of x over natural log of y. And really, I prefer the natural log because that's what you're going to be using in your next year's class. Let's say that you have log base 2 of 10. What you would change that to is log base 10 over log base 2. You would then plug that into your calculator and you would get an estimated answer, and that would be 3.322. And you need to try that just to make sure that you can do that. Okay, now I want to look at the graph y equals log base 3 of x. And I would first think about your original or your parent function of log, and it looks like this with an asymptote at 0. And so if you wanted to graph this, and let's do so, you're still going to have an asymptote at x equals 0. Let's try an xy chart or a t-chart. You're still going to have 1, 0. It's not going to change there. Then I would think of factors of 3 to help you plot the others. So let's start with 3. And so 3 to what gives you x, and that would be 1. So at 1, 2, 3, you're going to plot 1. The next factor would be 9. So 3 to what gives you 9, and that would be squared. So let's see, way out here at 9, it would be 2. See, the next one would be 27, and that would be 3. And I don't have room to plot that, but basically your function is going to go like this, and then it's going to cut right back down your asymptote, which basically looks like your parent function, but it gives you an idea of what happens to your base and how it's going to change your graph. If you were to do this in your calculator, you were going to have to do your change of base. So you could plug that into y1, and you could do a change of base of log of x over log of 3. And you could look at the graph and see how it looks on your calculator. Okay? All right, now let's do some solving and see what happens when you're given an equation and how you're going to use your log in order to solve those equations. So when you have 3 raised to the power of x plus 2 is equal to 7. Now what I would do to this is I would add a log or a natural log to both sides. Remember, if you do something to one side, you have to do it to the other. Now you can use log or natural log. I'm going to use natural log because you basically just have to write less. So I'm going to say natural log of 3 raised to the x plus 2 is equal to natural log of 7. Now remember your rules from the day before. If you have an exponent, it comes down as a coefficient. So x plus 2, I'm going to put that in parentheses. Natural log of 3 is equal to natural log of 7. Now my goal is to solve for x, so I'm going to divide by the natural log of 3. So I have x plus 2 is equal to the natural log of 7 over the natural log of 3. And so now I can get rid of that 2. So x is equal to negative 2 plus the natural log of 7 over the natural log of 3. And you could leave this as your answer if I was just asking you to simplify, or you could plug this into your calculator and get an answer from this. All right, and also if you use log, these could be logs, but you cannot combine the log and the natural log together. Okay, let's see what I do over here. Again, you have e raised to an exponent, so I'm going to natural log both sides. So natural log e raised to the 3 minus 2x, and that's equal to natural log of 4. Again, my exponent comes down to the front. So this is 3 minus 2x and natural log of e to the natural log of 4. Now this right here, natural log of e, is equal to 1. So natural log of e is equal to 1. So I have 3 minus 2x is equal to natural log of 4. In order to get x by itself, I'm going to move over the 3. So this is negative 2x equals natural log of 4. And so x is equal to, oh whoops, I forgot my 3, minus 3. So natural log of 4 minus 3, and that is going to be divided by the negative 2. And then again, you could plug that into your calculator to get the final answer. Okay, so hopefully some of you are looking at number 3 and not being too scared about it, but if you notice, you can see a trinomial. So what I'm going to do is I'm going to let e to the x equal u, or I should have said let u equal e to the x. So I'm going to do a u substitution. So this is going to be u squared minus u minus 6, so that I can simplify this sum. And this is going to be u minus 3, and this is going to be u plus 2. Since this is equal to 0, I'm going to have to go ahead and solve. So this is u equals 3 and u equals negative 2. I can go ahead and plug my e to the x back in. So this is e to the x is equal to 3 and e to the x equals negative 2. All right. So now I have a mess here, and so I'm going to have to natural log both sides. So natural log of e to the x is equal to natural log of 3. Remember, e to the x is 1. So if I have x times natural log of e and natural log of 3, that's 1. So x is equal to natural log of 3. And over here, again, if I natural log e to the x and natural log negative 2, this is 1, so x times natural log of e is equal to natural log of negative 2. I have x equals natural log of negative 2. Now, this is the first time that I'm coming up with a problem that we need to do this for. So this is the first time that I'm going to mention it. Remember before when we were checking for extraneous solutions? Especially with logs, we're going to have to do this. And this would be a time. Anytime you come up with a log of a negative number, this would be a clue that you're going to have to do this. So I'm going to plug this back in. You never can take a log of a negative number. Remember when you have your log function, if you notice you have an asymptote at 0, so you can never take the log of a negative number. So if I ever were to get this, I would cross this out because you can't take that. But I'm going to check log of 3 and plug that back in to see if I would get a negative number. And you can plug it in anywhere to make sure. Okay, my next problem, it looks like I can take out a common factor. How about x and e to the x? That leaves me with 3 plus x is equal to 0. And I'm going to set each one of these equal to 0. I'm going to set x equal to 0. I'm going to set e to the x equal to 0 and 3 plus x equal to 0. These are two different variables, so I'm going to set them each to 0. So I've got x equals 0 here. I can natural log both of these, so hopefully this is getting easier for you and y'all are catching on to this natural log of e. So I've got x equals natural log of 0 here. And then this is going to be x equals -3. All right, let's check for extraneous solutions here. Okay, if I plug in a 0 for my x value here, then that gives me 0, and that gives me 0, so this one works here. If I plug in a natural log of 0 here, if I plug in a natural log 0 here for my x value, then e is raised to the natural log 0, and e raised natural log 0 there, then I do not get 0. And -3 is also going to work. Okay, let's try this one. Okay, this one actually has a log in it, so I'm going to leave it. How about we subtract 4? So this is going to give me 3 log of 2x, and that is going to be equal to 6. And then I'm going to divide by 3, so that gives me log of 2x, and that's equal to 2. Okay, what I'm going to do from here is I'm going to go to exponent form. When I get stuck, if you already have logs, then you can't re-log that, but you can go to exponent form. So when you don't have a base, remember your base is 10, so that would be 10 squared is equal to 2x. So really this is 100 is equal to 2x, and so that means that x is equal to 50. Okay, if you plug 50 back in, does that give you an extraneous solution? And it doesn't, so that's going to work. Okay, number 6. Again, this is already logged. Okay, how about one of your logs? Remember when there's a plus, I'm going to take this logs and take one big log. Together, combine these. So this would be x plus 2, and multiply that times x minus 1. And that's equal to 1. I can go ahead and combine those. So that's going to be x squared plus x minus 2. Okay, I'm going to do the same thing as I did here and go to exponent form. Remember, your base is 10, so that would be 10 to the first power is equal to x squared plus x minus 2. So we have 100 is equal to x squared plus x minus 2. Oh, I'm sorry, not 100. That is craziness right there. So I can move that over and set it equal to 0. So that would be -12, and I can factor that. So it'd be x plus 4 and x minus 3. Therefore, x is -4 and x is 3. Okay. Let's check our extraneous solutions. So this would be 3, that would be 5, and that would be 2. So 3 works. And then if I plug in a -4, that gives me a negative number, and I'm stopping because I already got a negative log, and you can't have that. So that's extraneous solutions. Okay. And this looks like our last problem. It says, how long will it take $5,000 to double at 8.5% compounded quarterly, or how long will it take it to triple? Okay, so we have our interest formula here. So we're going to take $5,000, plug it into what we begin, and I'm going to double it. So if we double it, that would be 10,000. We start with 1 plus our rate is going to be 0.085. Our N is going to be quarterly, so that would be 4 times a year. So let's see, if we divide that, that's going to be 2. I still have my 1 plus 0.085 quarterly. Okay, so in order to do this using log, so now we're kind of at a standstill doing this by hand. What I would do is I would natural log both sides at this point. Okay, so I would add a natural log. You could log, but again, I like natural log. You could go ahead and put this in your calculator, but since you're doing this by hand, you're showing me all your work here. This is raised to the 4t. Remember, your exponents come down as whole numbers, so this would be natural log of 2. This would be 4t, natural log of this nasty decimal here. To move up here. Okay, I would probably divide all of this, so you have natural log of 2 over natural log of the decimal, 0.085. This is equal to 4t. You could, at this point, go ahead and plug this all into your calculator, and then you could divide by 4. So I got t is equal to 8.24, and that would be years. And that would be my final answer.